Okay, good morning everyone. Am I audible?
Yes, sir.
Good morning, sir.
Okay, so in our last class, we were discussing about binary operations. So, can you recollect what we discussed in our previous class about binary operations? What are the properties or characteristics a mathematical operation should have if we have to call it a binary operation? Can you recollect? What are the characteristics? Of a mathematical operation should be there if we have to call it a binary operation. Can anyone recollect? Okay, anyway, so there has to be three characteristics that should be there if we have to call a mathematical operation as a binary operation. And the three characteristics are uniqueness, well-definedness, and closure property. So on the basis of these three, we discussed in our previous class that these three operations, as you can see on the screen, are binary operations. Now, if we carefully observe, so here what has been done, how we can operate two elements are actually defined as per the definition of the binary operation. As in this case, you can see in each of the three cases it is defined how you can define when two elements are being operated. Now the issue is how we will define when three elements are being operated. For example, in this case, the question may be how we can define if I have one more element being operated there. Say, I am asking how we will define A star B star C. Is it at all having any meaning or not? So now, A star B star C means when three elements are operated can be looked upon into two perspectives. One, as per the definition, you know what will be the result when two elements are operated. So I can think of this operation as A star B star C, or I can think the operation as A star B star C. Let us see what happens in each of these three examples. So if I consider the example 1, the first one, as per the definition, A star B is equal to A. That means the first element is returned. Okay, fine. Let us pick up three arbitrary elements from the set of natural numbers. Here I am doing the operation for the set of natural numbers. Fine. So let us see first. I am trying to find out 2 star, 3 star, 4. Fine. That means I can look into this as 2 star 3 star 4, or I can look into this as 2 star 3 star 4. Now here, that means the result will be 2 star 3 as per the definition of the operation. The first element is being preserved. So the answer will be 2 star 4. That means the answer is 2 as per the definition. And here it will be 2 star. Here the element result is 3 and the end result will be 2. So both are same. That means here it doesn't matter whether you interpret this element as this way or this way. Nothing changes. The answer is actually same. Okay, let us try to do it for the second operation and let us see what happens. That means if I do 2 operated with 3 operated with 4, that means I'm talking about the second definition. So this again can be interpreted in two ways. Say 2 operated with 3 operated with 4. That means that is 2 operated with 3. As per the definition, it is the max of the two element. That means this is 3 operated with 4. That means this will be 4. And in the second case also, what will be getting 2 operated with, sorry, this will be 2 operated with 3 operated with 4. That means this will be 2 operated with 4. That means again this is 4. So both the answers are same. So here also this is a kind of well-defined symbol because you can interpret in any ways you get the same answer. Now let us look at the third case, third binary operation, and let us see what happens. So if we look at the third binary operation, which was a to the power b, then let us do the same thing. If I do 2 operated with 3 operated with 4. Now this if we interpret as 2 operated with 3 operated with 4. That means first I will make these two operations. So it is 2 cube whole to the power, sorry, 2 cube. Okay, let us keep it in this way. Operated with 4. That means a to the power b. That means 2 cube whole to the power 4. That means this is 2 to the power 12. Now, if we interpret the same thing in another way, first I will operate the last two, then I will operate the answer with the first one. Then what will happen? 2 operated with 3 operated with 4. So that means 2 operated with 3 to the power 4. That means this will be as per the definition 2 to the power 3 to the power 4. Now 3 to the power 4 is what? 2 to the power 81. So you can see that two are not same. So this is a kind of ambiguous symbol. The symbol is kind of ambiguous. The answer is not certain. If different people interpret in different ways, they can get different answers. Is it clear?
Yes, sir.
Means unless you people interact, I cannot understand, or otherwise I will. It
Yes,
will
sir.
be kind of recorded lecture playing.
Yes, sir.
Yes, sir.
I can do that also. I will record my lecture and play in this session. If you people think that you will relax in your home and only by joining the class you will sleep, then it cannot be done in that way. Unless you interact, I cannot understand whether what you are getting or not getting. So if you are okay with that, I can record my lecture and play in this session. Do you want that?
No, sir.
Or I have recordings also. I'll just play in this session. If you don't interact, what is the point in like disgusting? Anyway, so the point is, uh, mm, there are certain binary operations where this kind of operating three elements is a well-defined kind of symbolism. Means there is no ambiguity. You can operate them in any way you like. Means without changing their order, of course. Means in this kind of a symbol can be interpreted as A operated with B operated with C. Means first you can operate these two, and the answer can be operated with the first one. Or the first and second can be operated, the answer can be operated third one with the third one. There are some binary operations where this will create no problem. The end result will be same. But there are some binary operations where you cannot do that. You need to keep in mind that in which order you are doing the operations. So you can understand that this actually varies from binary operation to binary operation. Now, can you tell me which kind of binary operation you will prefer to work with? Which kind we will be comfortable to work with? Where we have to think about the order or where we need not have to think about the order? Means these two or this one? Which one is
Where we don't
more
have to think about the order.
where we don't have to think about the order, correct? So now keeping this in mind, such kind of binary operations are known as associative binary operations. So a binary operation is said to be associative. A binary operation star, a binary operation star defined on a set S is said to be is said to be associative if A star B star C is equal to A star B star C. Now this is important for every, this symbol stands for all A, B, C chosen for any ABC chosen from the set. This symbol, I hope you know, stands for all. So for every ABC, if I pick up any three element ABC from the set, then A star B star C will be equal to A star B star C. This is a very important a property of a binary operation. You can understand if we have associative, if our binary operation is associative or if the associativity holds, then we do not have to think about the order. We can bracket them in any way we like. We can group them in any way we like. So that is one observation that we are getting here. Any doubt about associativity? Is the definition clear?
Yes, sir.
Yes, sir.
Yes, sir.
Now,
Yes, sir.
sorry. Now, again, if we think about another thing, another aspect of these three binary operations, say, I hope you can now remember what are the three binary operations. The first one is retaining the first element. The second one is choosing max. The third one is a to the power b. Is raising the second element to the power of the first element. Okay, fine. So now again, if I do a simple observation, say if I do 2 star 3. So what will be that as per the definition of star?
2.
2. Okay. If I do 3 star 2,
3.
that is equal to 3. That means these two are unequal. Okay. Now, if I do 2 operated with 3, this is the second binary operation of the context. What is the answer?
3. 3. 3.
The answer is 3 because we are choosing the max according to the definition of this binary operation. Now, 3 operated with 2,
3. 3.
that is also 3. So, good. Yes. Now, 2 operated with 3. This is raising the second element to the power of the first element. So 2 to the power
3.
3. And if I do similarly 3 operated with 2,
3 to the power 2.
are the two same?
No.
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 So we can see again, there are some binary operations for which A star B means if I operate them in any ways, the ordering does not matter. But there are some binary operations where the ordering matters. Is it okay? There are some binary operations where the ordering does not matter, and there are some binary operations for which ordering matters. Again, the same question: which kind of binary operations we will prefer to work with? Means in some case of kind of binary operations, so we don't have to think about the order. We can operate them in any order we wish.
Sir, where ordering doesn't matter, sir.
Where ordering doesn't matter, so that will be kind of, we will be comfortable because you need not have to have anything extra in our mind. Now those kind of binary operations are known as commutative binary operations. So a binary operation star defined on a set S is said to be commutative if A star B is equal to B star A. Now the important thing is that for all A, B chosen from S, it is not that for some element you are seeing that the results are like A star B equal to B star A, and for some other pair of elements the result is not like this. Then we cannot say that the operation is commutative. If the operation is commutative, then if we pick up any pair of element and operate them in any order we wish according to the operation of the context, the answer will be same. Is that okay?
Yes, sir.
Yes, sir.
Okay.
Yes,
Now,
sir.
can you tell me about the known mathematical operations that you have read so far? How many of them are commutative, or can you give me some examples of commutative and non-commutative mathematical operations, which are binary operations you have read so far?
So addition and multiplications are
Addition
commutative,
and multiplication are
and
Just a minute,
commutative.
subtraction and
just a
division.
minute, just a minute, just a minute. Whenever you say a binary operation, whenever you name a binary operation, see how I have written a binary operation star defined on a set S. So when you say addition, you have to say on which set you are defining addition. Is it okay? Whenever you say multiplication, you should say which set, or any other operation, you should clearly mention the set also. Otherwise, we have seen earlier that a same binary operation, that the same mathematical operation can be a binary operation on some set, cannot be a binary operation on some other set. Correct? So we need
Yes,
to
sir.
say very clearly, whatever sentence we utter, we should be logically correct. So now, addition on which set you are talking about? Set of
Real
real
number
numbers? Okay. So
and
addition
multiplication
on
also
the set of real numbers is a
commutative.
Commutative.
commutative. Okay. Is that associative? Is that associative too?
Yes, sir.
Yes, sir.
Yes, that is associative too. Okay. Anything else? Somebody was saying something else also, I guess.
So multiplication sign on real number,
Multiplication on the set of
real number,
real numbers. That is commutative and associative both.
associative. Yes.
Okay. Okay. Anything else? Anything else?
Max and mean,
Max
both are
and min means
yes, on set real
on
number,
the set of
real
real
numbers,
numbers. Okay. What is that?
commutative.
Commutative. Correct. Commutative. Will that be associative? Will that be associative?
Yes, sir.
Yes, maximum means that will be associative, minimum will be means
Yeah,
you do in any order, you will get the same answer. Correct. Acha. Apart from this, now, acha, subtraction, if I consider on the set of real numbers,
it is
subtraction on the set of real
Non-commutative.
numbers, Non-commutative. Very good. Non-commutative. Very good. And what about associativity? My operation is usual subtraction on the set of real numbers. What about associativity?
Non-associative.
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 Very good. Division on the set of. Can I define division as a binary operation on the set of real numbers?
But it won't be commutative.
No, sir.
No.
So
Division on
we
which
can
set? Division on which
real
set?
numbers. You told that question.
No, I said can we
So
define
it is
division as a
non-commutative on
binary
real
operation
number.
on the set of real numbers?
No, sir.
No. So how I have
No.
to define if I have to talk about division? At max on which set I have to define? I discussed this in the previous class also. See, there's a section on division in the previous class. So if I have to say division as a binary operation, what should be my set? Underlying set?
Real number minus 0.
Great. Set of non-zero real numbers, and on that set division is a binary operation. Now, is that binary operation, that is division, commutative or associative? What is your take on that?
Non-commutative.
Non-commutative. And associativity?
And non-associativity.
Okay, non-associative. Achha, apart from these numbers, say my set is the set of all square matrices. Now we know, we have read two operations, say matrix addition and matrix multiplication. What we can say about that? Them? My set is the set of all square matrices. Means I am defining by symbol as MNR. Means the set of all n by n square n by n real square matrices, means whose entries are all real numbers. Real square matrices. Now, and if as an operation I am considering the addition of two matrices and multiplication of two matrices. First of all, will addition of two matrices be a binary operation here? Will addition of two matrices be a binary operation here?
Yes, sir.
Okay. Multiplication of two matrices be binary operation here?
Yes, sir.
Okay. So addition of two matrices and multiplication of two matrices are binary operation here. Will they means if I consider addition of two matrices, will that be commutative here?
Yes, sir.
Achha. So will that be associative?
Yes, sir.
Okay. That means plus, if I consider that is usual addition of, that is addition of two matrices, and since I have taken square matrices, any two matrix is compatible for addition, right? Otherwise, if you choose rectangular matrices, then there may be problem. Operation must be defined in a way that the two matrices are compatible for addition. But since I have chosen square matrices, if I pick up any two matrices, I can do addition, I can do multiplication. So addition of two matrices of M and R. is a commutative will this be associative?
Yes, sir.
And associative binary operation on MNR. Okay, fine. Now, what about multiplication?
Maybe commutative, maybe yes, may not be commutative.
Maybe there is nothing like maybe. Communicative, not communicative, commutative.
Sorry, sir. Commutative.
There is nothing maybe. Either it will be commutative or it will not be commutative. Why you are saying maybe?
In some case, it might be commutative, sir. A, B.
No. What is meant by that I have explained. What is meant by this commutative? This is for all AB. For every element, I have told categorically that. For every element, if this happens, then we will say commutative.
Oh,
Just listen to what I'm saying. If it is happening that for some element it is true, for some element it is not true, then we will not say it is commutative. That's why this is important for every element. Got my point?
yes, sir.
So what will be my conclusion?
Not commutative.
So this is not or non-commutative, I will say non-commutative. And what about associativity? Is matrix multiplication associative?
No, sir.
Matrix multiplication associative or not? Just think, take some time, think.
It's associative.
You have read matrix theory, I guess,
Yes, sir.
in your
Associative.
+2 level. So is it associative?
Yes, sir.
Okay, so this is non-commutative but associative binary operation. But associative binary operation on MNR. Okay, so is associativity and commutativity clear to you all?
Yes, sir.
And remember, that is
Yes,
very
sir.
important that it has to happen for all. Then we will say only commutative. So now, tell me another important thing. Can you tell me when we define addition as a binary operation on the set of real numbers, addition on the set of real numbers, what is the role that zero plays there? Or when we define multiplication as a binary operation on the set of real numbers, what is the role that one plays there?
So it returns the same number.
The identity it returns.
It returns the same number when we operate any other number from any of the sides, means when we pre-operate as well as post-operate. Now, if we generalize that concept, then the element for a binary operation which possesses the same property as 0 for addition and 1 for multiplication is known as the identity element, which is a very important concept in group theory. There is identity element. Identity element. So what is an identity element? I'm saying let star be a binary operation defined on a non-empty set Are you understanding my handwriting?
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
Yes, sir.
On a non-empty set S, an element E an element E in S is said to be the identity element the identity element so this is very important concept of this group theory. Identity element is said to be an identity element of star in S if A operated with E is equal to E operated with A for all A in S. Again, this qualifier is important. So what I have written let star be a binary operation. There is a binary operation, say that is star. Star is any binary operation. Then an element E is said to be the identity element of star in S if A star is equal to E star A. Is equal to, sorry, is equal to, I missed one important thing, is equal to A for all A belong to S. That means if it returns the value which we operate with it, if it returns the value which we operate with it. Is it okay?
Yes, sir.
Yes, sir.
Yes, sir.
Means just keep in mind what is the role played by 0 in case of addition and what is the role played by 1 in case of multiplication on the set of real numbers. We have just generalized that concept here. Fine. So now the usual things, the usual operations which we have done so far, we know who are the identity elements. In addition, 0, as you have said, in case of multiplication on non-zero on the set of real numbers, it is 1. Now, in case of matrix addition on the set of n cross n square matrix, as I defined above, can you tell me what will be? Is there any identity element, or what will be the identity element? In case of matrix addition, what is the identity element?
Slightly.
Sorry. In case of matrix addition, what is the identity element?
The null matrix.
Absolutely correct, the null matrix. And in case of matrix multiplication, what is the identity element?
Identity matrix.
Identity matrix.
Identity matrix. Identity matrix. So my E is the identity matrix in that case. Okay. Let us now check the previous 3 makeshift binary operations that we were discussing. These 3. So these 3. Fine. Say as an example, my set S is equal to, say, the set of natural numbers n, and the first binary operation as per the definition A star B is equal to A. Am I correct? This was our first binary operation. The first element is retained. So now tell me, what is your identity element for this? What is your identity element for this?
Sir, all real number.
First of all, real numbers cannot be, because your set contains only natural numbers.
Sir,
This
all
is your
natural
set.
numbers.
You are doing this, defining this on the set of natural numbers.
Oh, sir, I didn't saw the set. That all the natural numbers.
All natural numbers. Forget about all. Can you tell me one? Means anyone. Just name anyone.
Like 1, 2, 3,
One.
anyone.
Okay. One. So if one is the identity element, as per the definition, what should happen? If I operate any other element with one, both pre-operate and post-operating, I should get back that element, right?
Yes, sir.
Acha. Tell me any other natural number, or pick up any other number from your set.
Sir, 4.
Sorry?
2.
2.
Two.
Okay, very good. So 1 operated with 2 and 2 operated with 1 should be same as per the definition, because the definition of identity element is that. Am I right or not?
Yes, sir.
Acha. Now, as per the definition of your operation, what is 1 operated with 2?
1.
1.
1.
And what is 2 operated with 1?
2.
2.
2. Therefore, if 1 is the identity, if 1 is the identity of star in n, then what has to happen? Then 1 operated with 2 should be equal to 2 operated with 1. Am I right or not?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
That should be equal to, means 1 equal to 2. That will imply. Can it happen? Can it happen?
No, sir.
No,
So
sir.
it is a
No,
clear
sir.
contradiction, correct or not? Now
Yes.
similarly, you pick up any other natural number and claim it as identity, will land up to this kind of a situation, right or not?
Right, sir.
So what is our conclusion? The conclusion is this binary operation does not possess any identity element. Am I right or not?
Yes, sir.
Yes, sir.
If I let this is let 1 be the identity element, now instead of 1, if you pick up any number as identity element and do these steps, you will get similar contradiction. Am I right or not?
Yes, sir.
So therefore, what is the conclusion? Therefore, star possesses no identity element. Right? Have you
Right, sir.
understood clearly? So
Yes, sir.
now we actually do not realize, so far whatever mathematics we have done mathematics with very, very decent, very nice, very sober mathematical operations, which possess identity elements, which had been commutative, which had been associative. Everything was very nice. But believe me, most of the binary operations or mathematical operations in world, which we will encounter in practical life, are not so decent. In most of the cases, we will see things are not going so nicely. And since we always have got identity element for our binary operations, we have done everything very easily. But I will show you in this course. And even we have not realized what are the importance of getting identity element for a particular binary operation. We have not realized that because it was natural. the role that is played by 0 in case of addition or 1 in case of multiplication, we thought it's like natural. We do not valued it. Means people say sometimes that till something is in your possession, you do not understand its value. You will understand its value once it is gone. So it is similar kind of thing which will happen in this course. We will understand that when we do not have any identity element for a binary operation, we will see that we will face lots of difficulties in several places if we go with that binary operation. So yes, there can be binary operations which will not have any identity element. That's why to write it more correctly, I can add a few words here. An element E within bracket, if any, means you can understand here that when I have said an element T, I am not saying that such an element will definitely exist. Got my point? Means I'm not saying that such an element will definitely exist. If exists, is that kind of an element can exist, cannot exist. Is that okay? Have you all understood?
Yes, sir.
Yes,
So
sir.
your first task is if I write as homework, your first homework after this class will be test the same for the other two examples that I have given. Two means test the same for our notation or symbol was say something like this and this, right? Can you do this? Can you do this checking? Can you all do this checking for these two, for the other two binary operations? These two? Yes or no?
Yes, sir.
Okay, try to
Yes,
do.
sir.
Sir, could you
Fine.
repeat once again? Your voice is breaking.
This whatever I said, it is written. Test the same for these two. Means the other two binary operations. Now I am defining another binary operation. Say A star B is equal to, I am defining as A plus B minus 2. Where A, B are again the set of integers. Where A, B belongs to the set of integers Z. This Z means set of integers. Are you aware of this symbol Z? What is the difference between this N and this S?
So n is the set of natural number.
And Z is the set of integers. What is the difference between the two?
So 0 is not
0, 9
included in natural
actually.
number.
In
Zero.
natural number, 0 is not included.
Acha. And anything else? In natural number,
So
0 is
natural
not
number should
included.
be
In Z,
positive
0
number.
is included. Anything else?
The integer can be negative or positive.
Yes. Instead of
Yes,
natural
z
numbers,
plus and z
negative
minus.
integers are
It will
not
be
there.
always
Instead of
positive.
integers, you have negative integers also. Correct. So this is your set S. So S is actually this set of now integers Z. And my binary operation is this. Now your question is find the identity element. So how to find that? Okay, let E be the identity element. Let E be the identity element of star in Z. Okay? Then if E is the identity element, what will happen?
A star e is equals to a plus e minus 2.
Then A star E will be equal to E star A, correct?
Yes.
Yes, sir.
Okay, very good. Very good. That is, which implies A star E means what? A plus E minus 2 is equal to, and that is equal to A star E equal to E star A equal to what?
A.
A. So A star E means A plus E minus 2, E star A the same, E plus A minus 2 equal to A, correct?
Yes, sir.
Yes, sir.
Therefore, A plus E minus 2, I can pick up anyone, is equal to A, which implies E equal to what?
2.
If I solve for E, because I need the value of E now.
Two.
So what is the
2.
value of E?
2.
2.
Is equal to 2. Therefore, 2 is the identity element. Therefore, 2 is the identity element of star in this Z. Now you can test it. You can check also. How you will check? Pick up any element. Say I'm picking up 5. So what should we get if I operate 5 with 2, say 5 star 2? What should be my answer? As per the definition of identity
5.
elements, since 2 is the
5.
identity element, 5 star 2 should be 5. Okay, let us check it. So 5 stars 2, as per the definition, it will be 5 plus 2 minus 2, that is 5. So then you can pick up any other element. You will see that if you operate with 2, you are getting that element. You will get that.
Yes, sir.
Yes, sir.
Yes, sir.
Fine. So now number 3. Absolutely clear? So whatever role is played by 0 in case of addition on real numbers, the same role is played here by 2 in case of this operation star on the set of integers. Right or not? Right or not? Now, I'm giving one more operation. A star B is equal to AB plus 1, where A, B are, say, integers, and my underlying set is also set of integers. Now, can you people find out the identity element for this binary operation? First of all, is it a binary operation? Is it a binary operation?
Yes, sir.
Okay. So, fine. Fine. I'm keeping this problem for you also. Now, the question is, check whether star is commutative, associative, commutative and associative, number 1. And number 2, find the identity element of star in Z if exists. Can you solve this problem?
Yes, sir.
This is a pretty simple problem. Can you solve it just like the previous problem?
The identity element is
Don't say the answer. Let everyone do it. I'll ask about the answer in the next class. But can you all solve it? Any doubt, any question you can ask me. See, this initial 2-3 class for abstract algebra is very, very important. You have to understand these concepts very clearly. If you understand these concepts, these simple things very clearly, rest of the subject will be pretty smooth. Otherwise, you will face too much of difficulty when I will go much deeper. These are pretty simple things I'm explaining, but you need to understand very, very clearly and carefully. For any question, you can ask me. If you have any question, you can ask me. किसी को कुछ पूछना है तो पूछ सकते हो, कारो কিছু জিজ্ঞাসা করার থাকলে করতে পারিস। I understand Bengali, English and Hindi, so you can ask in any language if you wish. Among these three, I don't understand Chinese, Japanese and any other language, so don't ask me in those languages. এই প্রবলেমটা সলভ করতে পারবে তোমরা? Can you people solve this problem?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
So
Yes, sir.
that's it for today. We will meet again in the next class. So I assume you have nothing to ask. So I'm stopping this screen presentation. Okay. So have you all joined Google Classroom?
Yes, sir.
Yes, sir.
Mhm.
Yes, sir.
I guess no, sir, because 54 students have done the class. And in Google Classroom, I don't have. Oh, this is the last one. I have 51 students only. So everyone join Google Classroom. Okay, that's it for today. Take care. See you again on Friday. You have another class, I hope, from 12. So join that class quickly. I've crossed my time limit already. Chalo, bye bye. Take care.
Bye, sir.